Welcome everyone to this session. It is called Understanding TCP Conversation Completeness. Welcome, welcome, welcome. For the next riveting 75 minutes, I'll be your host. My name is Chris Greer. If we haven't met before, I'm here because I love to give presentations. Apparently not, because that's the standard, this is the default text that they put in our slide presentation. So anyway, you can find me at Packet Pioneer. If we're just meeting, so I'm a Wireshark trainer. I like to talk about packets. Maybe I met some of you in the pre-conference class that we had before the conference began. It was nice to see some familiar faces here in the audience. I have been a SharkFest presenter for a number of years now, and I really, really, really love this conference. I love that I have a fellow I have several SharkFest instructors over here that are sitting in my session, and the next one it flips and you turn into a student. So I think it's a great learning environment. We're all here to share ideas and learn from one another. So welcome. All right, so what are we going to talk about today? Well, we're going to talk about this little field, and I'm actually just going to deviate from PowerPoint for just a moment because I just want to show you what I'm talking about. If you just bring up a PCAP, oops, I don't know if I'm on extended monitor, aren't I? Okay, 1 second. There we go. Just so you know that the PCAP that I'm going to be working with today is the one from the CTF. It's the last one that Tony has it's the final, I think it's the 700. If you just go out there and grab that PCAP, don't worry about decrypting it or anything, and no, I'm not giving away any secrets from the CTF, but I'm just going to use that since everyone has quick access to it on the CTF, or hopefully has access to it. If you don't, there's a nice gentleman here named Saka, and he's got a bunch of access to that system. He can probably set you up if you have any problems getting to it. But anyway, that's the one I'm going to use because just first off, let's go ahead and just click on packet 5. Now, if you are on a version of Wireshark that is 3.6 or newer, you're going to find, as you just mosey on down the packet headers here, you're going to find that there's this nice field called Conversation Completeness. Now, you notice here that we have our brackets here, right? Those straight brackets. Now, that means that this is not actually a part of the TCP header specification, okay? This isn't TCP doing this. This is Wireshark saying, hey, there's some information that could help you out with some analysis. Wireshark is doing this for us. Okay, so we see that in several different fields, but this one popped up. Now, this popped up in version 3.6 of Wireshark. I was actually teaching a class. I had everybody, I think some people were on 3.5 or previous. I had just updated to 3.6. Everybody gets on the same packet page, so to speak, and then a hand shoots up in my course and says, hey, Chris, what's conversation completeness? And I went, that just happened. So I'll get back to you. But yeah, so it's a somewhat newish feature. It's an evolving feature. It's not done yet, right? What are we on, 3.6.6? Not you, Saki, you're on whatever. But the mortals in the room like me, yeah, 3.6.6 or so. So this is it's a feature that's emerging. I hope it'll continue to have different features or capabilities that come along with it. But what I wanted to do today was just introduce you to this field, how we come up with this number. And if you notice, you see this 31 here? So let me do this. Do you see any other packets in this PCAP with a different number? Let's do that first. In fact, what I'm going to do, I'm just going to take this, I'm just going to throw this up here as a column, and I'm just going to take a little walk. I got 31. If I want to, I could sort it and be all handy and stuff. Sorry, I'm a scroller, just looking through. Got a bunch of 31, so clearly 31 means something. Do we see anything that is not 31? I did last night. If I jump down to the bottom. All right, I got some 63. I got, what else? What other values here? And you notice that I don't just have the numeric value, but I also have this little description thing. Complete with data, 63. All right, you might notice that there's some 31s in there. You might notice, I can't remember, I think we do have an incomplete in there. If not, I'm going to show you one, maybe even give you another PCAP. All right, what on earth is this? How do I use it? What's that number all about? And how can this actually be practical to help me troubleshoot? Well, when we think about a TCP conversation, all right, let's just do this. There we go. So let's think about the life of a TCP conversation. Okay, so TCP connects. Typically, something is exchanged, and then the conversation shuts down. All right? Let's keep it simple. Those are our 3 big steps. Okay? Open, something's exchanged, data's closed down. But how many times have you ever started a capture after the handshake? That ever happened to you? Oh, come on, every hand should go up. That happens to all of us. Of course. Maybe it's not intentional, but sometimes you catch after the handshake happens, right? So we have our handshake, it goes, sin, ac, and whoops, we started capturing after that. Okay. So this is just one thing that can happen when we're doing our analysis. So in that case, according to our capture perspective, the PCAP itself might not have from start data to finish all in that same PCAP. Maybe it's in a different capture if we're in a ring buffer, or maybe we were just doing a time and place capture at one point in time, and that handshake is gone forever. Okay, so this is just one thing to think about. Sometimes we start capturing after a handshake, and that conversation could look incomplete. Another problem, we think about filtering. What if I just had a huge handshake and I just wanted to just look at the handshake part of it? What if I just want to take a look at a bunch of handshakes? Or maybe I want to examine just any half-open conversations. All right, that's where a SYN went to the server kicked back a SYN ACK, and then that was it. So now the client's happy. The client's like, sweet, we got a connection. Server's over there going, are you going to get back to me? Right, I sent you a SYN or SYN ACK. Okay, SYN ACK, SYN ACK, SYN ACK. So that's half open, all right? So I might want to know about that type of activity. How about another case? What if I have a bunch of, or I have a spike of activity where I have a SYN go, and then I get a reset, SYN reset on a server. All right, someone's trying to port scan, they're trying to enumerate, or they're trying a bunch of different ports, and I see just a bunch of activity like that happen. All right, so those are all types of TCP conversation behaviors that, whether I'm doing troubleshooting or doing some forensics, it'd be nice to get a pulse on how complete was that conversation, and I can do so just by looking at a single field now. So this is just one thing. It was a little bit cumbersome to filter for. Also, filtering for half open, right? That's a little bit cumbersome to filter for. Now, it's true, though, we could say, okay, Chris, we already have a way to filter on a TCP conversation. Come on, we can filter on the stream, we can filter on the port numbers, take the for tuple, go to statistics, conversations, and pull out all this conversation stuff. But did we capture the handshake and teardown? Was data exchanged at all? Was the connection reset or not? You see, TCP Conversation Completeness allows us, with just a glance, to be able to tell, did I get the handshake? Was it successful? Was data exchanged? And how was it torn down? I don't have to scroll up, scroll down. I don't have to wonder if all of that activity, so to speak, is actually in my PCAP. When I'm on a packet, I can tell this just from conversation completeness. So it's a field that tells us about how much of that conversation we received and what aspects of TCP were contained therein. All right? That's what conversation completeness is. Okay, now let's go down into the weeds a little bit. All right, so do we have a bit of a definition on conversation completeness? It's just a field in every single TCP header for that whole conversation that allows us to take a quick glance of what was captured. What aspects of TCP do we see from start to finish? All right? Now, I've already shown you it. Now remember, this is a new feature from 3.6, so if you're in an older version, 3.5, might want to take a peek at a newer version there so you can actually see this field appear for you. All right, so next I'd like to actually talk to you about how this whole thing works, all right? What's the mechanics behind it? And just so you know, I'm not, this isn't just a bunch of smoke and mirrors. This is all actually on the Wireshark user guide. You can actually go into Conversation Completeness and see all this, so, or watch it later on YouTube. But basically, I want to show you the values that get assigned to each step in the TCP conversation process, okay? So let's back up. When I first start a TCP conversation, I send a SYN. That goes to the other side, right? SYN, and you guessed it, SYN-ACK, ACK. Now, our handshake has been established. Both sides are happy. Both sides are aware of the starting sequence numbers. Data can commence. Now, one side or the other can send data. We can even shoot data in the opposite direction. Then we shut down that connection. There's two ways to shut down that connection. I can either do with a nice polite fin, or I could do an abortive release with the reset. Talk to the hand, I'm out of here. We've all seen those. Nice bright red packets in our Wireshark screens. But this is what I'd like you to take a look at. If there's one thing that you come here to this session to remember, it's this. All right, watch these numbers come in. 1, 2, 4, 8, 16, and 32. Don't have to memorize this because it's on the Wireshark page for us to remember, but I just want you to walk through and think about the logic here. When you have a SYN, you basically get assigned a value of 1 when we see that happen in a conversation. If I ever see a conversation completeness of just 1, that means that the only packet that we got for that conversation is a SYN. A SYN is assigned to 1. Well, using the binary method of increasing this number, if I get a SYN-ACK, SYN-ACK is assigned to 2. The third packet of a three-way handshake, that's going to be assigned to 4. Any data payload after that, handshake's done. If there is any data whatsoever in either direction, from client to server or server to client, this is how it sits now, everybody. I don't know if this is going to change. Eventually, if it'll change according to client to server, server to client, whatever. For now, data in either direction is assigned an 8. Right? A fin in either direction is assigned a 16, and then finally a reset. Okay, so just let that marinate for a minute. It's all the pertinent parts of a TCP conversation. Not all have to be there, but if they are there, Wireshark goes, oh, check, 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 and then it starts to add. What's that mean? All right, let's actually put this to work. Let's see what this looks like. Okay, so client sends a SYN to server. Server does nothing. Okay, what kind of things could cause this? Any ideas from the audience? If I just send a SYN to a server, don't hear nothing back. Firewall? Packet drop? Port exhaustion? Server's busy? Those are the biggies. So I send a SYN, never got there, something along the way ate it. So yeah, so there's my SYN. So if that's all we see, then my conversation completeness value in that TCP header is going to be TCP completeness 1. Incomplete, SYN was sent. We saw SYN. So let's do this practically. If I open up a PCAP and I do a TCP completeness filter of 1, and I notice that 90% of the packets are SYN sents, right? Isn't that kind of steer your brain? Like, whoa, that's all we saw? No SYN-ACKs, at least for these conversations. Now that gives me a bit of an idea of what to go looking for. Either we're getting a bunch of packet loss, we got a firewall blocking this port, we're not getting through to that server, it's not responding, or the SYN-ACKs aren't coming back to us. Okay? TCP completeness 1. Now let's keep going down this chain. Let's add the next packet. All right, now we have, technically, by definition, let's just call this a half open, right? Client sends SYN, that SYN gets ACKed. He sends an initial sequence number, +1, ghost byte, sends back the ACK. Client's happy. Sweet. We've established a connection. However, for whatever reason, there's several, let's just say, nothing happens after that. All right, we might even see the server retransmit a few times, like, hey, are you there, buddy? So what would be my conversation completeness value here? Well, I got the SYN, that's a value of 1. The SYN-ACK is assigned a value of 2. This is going to be conversation completeness 3. What's the descriptor going to say? It's incomplete. Why is it incomplete? A half open's not a full conversation. There's no data. There's no teardown. That's all we saw. We didn't even get through the handshake. Okay, so this is an incomplete conversation. Conversation completeness 3. Now, do y'all notice if you're on a PCAP, if you take a look at that conversation completeness field, if you go down to the lower left, you're going to see in parentheses, there's a field there, a name that you could actually filter for. What's that field called? TCP dot what? I'm going to show you in a minute when I get back to my little PCAP, but you see this in the lower, we get your little cheat sheet, I call it down, we can get your little filter syntax. If you click on the TCP completeness field, go to the lower left, you're going to see TCP.completeness, right? Did I get that right? Okay. That's now a field that we can filter for. It's a field that we can graph. It's a filter that we can do other nifty cool stuff with. Okay, so incomplete, client established. This tells us the client was happy, we got our SYN-ACK, but we never saw the third packet of a three-way handshake for that conversation. All right, let's keep moving. Let's say we're in a situation, client, server, SYN-ACK. All right, now we have 1, 2, and 4. Let's add it up. If we only have a TCP conversation that is just a handshake, it's a complete handshake. We see it in both directions. TCP completeness 7. Incomplete, it's still incomplete. This is not a complete start to finish conversation yet. It is established, however. You see how that's a bit of a different descriptor. Now I know, okay, I have some established TCP conversations, but we didn't do nothing with them. With a glance, we look at that 7, we got a handshake. Now I know in the back of your mind you might be thinking, Chris, how am I supposed to remember all those numbers? Honestly, when you start plowing through PCAPs, you're going to start doing this number math pretty quick on your own. If you see a 7 now, you're going to go, oh. If you click on a SYN, there's now another thing that you can look for as you're digging through PCAPs. You click on a SYN and you see conversation completeness 7. I don't have to set a filter and scroll down or do anything else. I know, oh, this was just a handshake. It completed. Right? Off that one packet. Now, each packet, just to make sure we're clear here, each packet in that TCP header is going to have the 7, right, for that conversation, just to make sure we're clear on that. Every packet in that whole complete conversation will have the same value, just so you know. So it doesn't really matter which packet you're on. You're going to know the completeness of that conversation. Let's keep building this. Next. All right. Now, one direction or the other transmits data. Server to client, client to server. Right now, it doesn't care. If we see a payload there, then we know that data went somewhere. Okay? So that just being present now turns it into a different thing. It's not just an established conversation anymore, or an established connection. Now we're actually using that connection. So what do we do with the math? Well, if 7 is our handshake, 8 is our data, now we're at TCP completeness 15, there's our addition here, incomplete data. So now, if you see this, you're plowing through, you click on a data packet, incomplete data, 15, what do you know right away that you're missing? Fin or reset? Either it didn't happen yet, or we didn't capture it, or it's on another PCAP, or what have you. You know it's not in this capture. We do not have it. All right? Right away. We can just know. All right? Is that useful? I think so. It gives us a good context of our conversation. All right, good. TCP completeness. Good, so let's keep going here. Next packet. Fin. Again, direction doesn't matter. In the previous slide you saw I had data and then data. If I have data from server to client, and then let's just say I had data as well, client to server, I don't double that 8. The very fact that there is payload one way or the other triggers that data switch, if you will. Data's true, okay? So these don't add up. If I have 100 data packets, I'm not talking about 800. It's just the fact that there was data being carried one end to the other, that's all right? I had to kind of get my head around that concept, so that's why I'm telling you. Now, on the bottom, fin. So the fin is assigned to 16. Doesn't matter which direction it goes, server to client or client back to server. If there is a fin in this TCP conversation, now we have a value of 16. If I have a fin and then another fin in the opposite direction, hopefully there's a polite shutdown in each way, those numbers don't add. If you have a single fin one way or the other, if you have 2 fins, you get the 16, okay? All right, so what would Wireshark call this? What kind of TCP completeness would we see? Okay, TCP completeness 31. Remember what we saw in our PCAP just a minute ago? That first conversation now? Does that 31 make a little bit more sense? We opened up that PCAP, we saw a bunch of 31s. And you're going to see this now. If you have connections that are establishing SYN-SYN-ACK-ACK, data goes in either way, and then you have FIN-ACK-FIN-ACK, now you're going to have a 31 TCP complete with data. Sweet. That's a full conversation. We captured the whole thing. Congratulations. It gives us more context on what we were able to capture. All right. We good so far? Oh, yes.
Are we missing something? I need 2 fins to close, and I can be half closed with 1 fin. So there's actually 2 states of the TCP regime.
That's true. That's true. Honestly, I'm going to have to look into the rules to see if there's an indicator on server done or client done. Honestly, I haven't done that yet. Is there not? Oh, there's a question. Sorry, there's a question in the room, and that was, here we have a fin on one side, so the server could go, okay, we're shut down. The client, am I okay? The client doesn't yet have a fin, so does TCP completeness at this time make any delineation of that? I was saying I got to look into that, but my good friend Sake says no. I'll repeat for people on Zoom, don't worry. So Saka was just mentioning that it's not there yet. This was a submitted feature to an open source project. So really we're all learning about it and seeing its function. But that was one of the things, actually, Saka was good enough to go over some, he sent some questions my way about this presentation. And one of the ones that we talked about was, we can't tell who sent the data or who initiated the connection or the connection teardown based on this number. At this moment, it's one or the other, right?
There's a question from
Sure.
Zoom as well. Is TCP completeness hiding in stats anywhere?
Is it hiding what?
In stats?
In stats. Not that I'm aware of. The only place I've seen it so far is in that header. You can make a liar out of me if you go find it. Okay. Good. That's an excellent question. And I'm actually excited to see what happens with the feature, right? So, okay, next. Reset. So reset, continuing with our binary counting, we had our fin 16. If one or the other sends a reset, then we have a reset true of 32. That's usually when the number jumps up pretty significantly. You know, I mean, now that I've been looking at PCAPs through the lens of TCP completeness much more lately because of this presentation, now I can tell pretty quick if there's a reset on the end of the conversation, just because that number, boom, jumps up. Basically, if you have a number north of 32, you have a reset. If you have a number north of 32, you have a reset there. Because if you add up everything else without a reset, it's 31. Okay? Now, what would that be? Again, TCP completeness 63, it's considered complete. Now, at this time, we don't have a way of delineating this between finned or reset, right? Perhaps that's coming, who knows? But we could say complete, aborted or something, or, reset at the very end, server-initiated reset. I mean, you can see the potential here, right? This is definitely a beginning stage feature. Now, how about this? What if we had a scenario with no data? Have you ever been in a situation like that? You're analyzing an application and you have a client that starts a handshake and then there's some amount of time and then it tears it down? Or maybe we have a bunch of handshakes that complete and a few teardowns that happen, but no data. So it's possible that you could have a situation where it's complete, we had a start and a finish, but there's no data. That's also a definition. Okay? All right. In fact, I just illustrated that for you. So if we just take out that data, we could subtract 8 from our top level 63, and this is complete with no data. That's if we have both a reset and a fin here present. So if I have a 15, right, I'm talking about the handshake. That's where your math is going to start to get a little quicker. If you have a TCP completeness of 7, at least 7, then you at least had a handshake. If it's 15, you had a data packet. 31, you at least had a fin. And if it jumps up significantly, you had a reset in there. Okay. Whew, let's back up. How's everyone feeling so far about the math? Is that making sense? Okay. Just catching you up to speed, because when I first saw this feature, I'm like, what's 31? How am I supposed to use that number? But here we go. Okay. Now let's look at another scenario. What if we're in a situation, we have a client that's trying to connect to a server on a wrong port? What if we have somebody over here doing something a little nefarious? They're scanning. Maybe they're running through a range of port numbers on a server trying to figure out what's open. Maybe I have a high amount of SYN reset activity. Conversation completeness is actually an interesting way to see that quickly, right? If you ever have a 33, or kind of depends, I think I have a PCAP with this in there as well. If you ever have a 33 or a 37, if I have a 37, that means it's plus 4, right? So if the reset itself is a reset ACK, it'll consider that an ACK, and it'll do a 1, a 4, and a 32. But anyway, in my head, I go, okay, if I have some range, if I'm 33 to 37, then I know that I'm having connections that are being reset right away. Was there a question on Zoom?
Yeah, one question is, would a 12 be an ACK with data, but the ACK isn't necessarily part of the handshake?
Sorry, repeat.
Would a 12 be an ACK with data?
So yeah, if I had an ACK with data, but I had no handshake, no teardown, then I could see a 12.
And somebody asked to review TCP complete equals 31.
Oh, sure. You're going to see that one a lot. Let me back up to that slide. In fact, you know what? I'll do you better. Let's actually get into our PCAP, yeah? So let's, if you're in the room or in the sky, go ahead and open up, let's open up to the CTF. In the CTF, the final challenge has the PCAP that I'm going to use. And let me, just 1 minute, I got to disable mirroring.
One more question from Zoom.
Mm-hmm.
How would you get a 12 if there was no SYN, SYNAC, or did Joel miss something?
No, Joel did not miss something. If you see the ACK flag at all, then it goes, oh, there's an ACK in here, and then it's going to count it with 4, or at least that's what I've seen it do. Like, I think an example is if I catch something midstream, like literally after the handshake I start capturing, and before the teardown I stop, those are going to be my 12s. So it doesn't care which way ACKs are going in. If data is present on a connection, then that's where you're going to see your 12s. So, good question. You know what would be an interesting test is if we just take a data packet isolated, just that packet, no handshake, no teardown at all, and do we just get an 8? But likely that packet also has an ACK flag in there too that it's going to count with an ACK as well, and that'll give it 4. Does it? Saki was just saying it should check for bare ACK. So I should see at least a data packet and a bare ACK in order to qualify for the 4. Does that make sense? So thank you. All right, let me fix my screen, people. 1 minute. Got my little projector mode. I'm just turning it off. Did we do it? Okay, there we go. All right, good. All right, so let's just look at some conversations, shall we? So, again, I'm on the, this is the, let me get this out of the way, clean.pcap.ng, and I went ahead and added conversation completeness as a column. All right, so right here, I can see 63. This packet is a part of a conversation that has 63. So what components of the TCP conversation are in this conversation, or in this thread? What do I know right away? Did I catch the handshake? Sure did. How about, is there data exchanged? Yep. Is there a fin? Yep, at least one. Was there a reset? Let's test. Let me right-click that guy. I'm going to say conversation filter TCP. Let's actually see. All right, we got our handshake. There's my little coloring rules up top. So there's my greens, right? Sin, SYNAC, and then a third packet of handshake. If I scroll down to the bottom, I have both fins and resets. Okay, so I had a complete handshake, data exchanged, and then both a fin and a reset. Interesting. Now, actually, Saka showed me something just before my session that I hadn't thought to try, so I appreciate you showing me this. If I right-click this, I can actually say ignore or unignore packet. I'm going to try this. It should work on the fly. If I say unignore, I just ignored that one of the resets, and I'm going to ignore the other one. Let's watch this that number and see what happens. Let me come here, and I'm just going to say ignore packet. You see what happened to my TCP completeness? I just told it to ignore the 2 resets. I kind of took them out of the equation, and my number jumped down to 31. So now in this conversation, it's acting as if there was no, the dissector is acting as if there was no reset. So kind of cool, right? We did it on the fly. Okay? What else? Let's look for some other conversations that are not 31. In fact, let's set a filter. So if I take a look and I come here, conversation completeness with data, if I come down here, it says TCP completeness is the field that I would filter for. So I'm just going to come up here to my display filter, TCP.completeness. How about no? Or I could say does not equal. I'm just out of a habit putting it at the very beginning. There, I just removed all of the TCP completeness 31s, and then I'll say, and you also have to be TCP. Okay, so these are all the non-31s. 63, again. Let me sort this guy. I'm just curious to see what else we have. Jumping down to the bottom, 63. I thought I saw a couple other interesting ones. Coming up. Is that it? We only have 31 and 63? That's it? Okay. Well, tell you what, let's do this. Let me jump into a new PCAP. I'm going to pull, how about this? Let me pull from our little threat hunting course. Let's pull up some Nmap scans and see what those look like. All right. So TCP. All right, so right here, this first packet. Got a bunch of green here. Kind of comb through it. Right here, I can see that this is a SYN. All right, so from client to server. Now this is SYN sent. It's just a 1. So did I get a SYN ACK here in this PCAP? Do I have an ACK for this SYN? Nope. It's just a 1. That's the only thing that we saw about that conversation was just that first packet. How about the next one? Incomplete 37. So what components are going to be in this conversation? I obviously have a SYN. Usually easy to see the reset ones, right? Again, north of 32. Okay, so I have a SYN. I got a reset. Let's actually filter. Let's see what else we got. You go conversation filter, TCP. Okay, so this is an incomplete conversation. The handshake never completed. Data was not exchanged. And then we have this abortive shutdown. So it's incomplete. So why do we have 37? I thought a reset was 32. So we have a 1 for the SYN, a 32 for the reset. But now we have 37. What's the delta there? Right, so let's actually see here on the info, just a place that we can peek at it. You see reset ACK? So it's counting that ACK mechanism. Now this is how it is right now, okay? This is an emerging feature. Stick with me, everybody. We don't know exactly how these things will be grown and adjusted as we go forward. But that's why if you have an ACK in the reset, then you're also going to see this as a 37. Okay? For me, I've just kind of trained my brain. If I see anything from 30, if I see anything from 33 to 39 in that range, you know, then I know that those are connections that are being reset from the handshake. I either had a SYN and a SYN ACK and then a reset. So maybe Nmap was just testing a port. The port's open. Okay, shut it down. That stealth scan. Or I test a port and it's not open, so it kicks me back a reset. If it's just a reset, then it's going to be 33. If it's a reset ACK, it's going to be 37. So we start to see some of the behaviors. So we can start to see on the wire just quickly. And I don't have to filter for that. I know just from that field what was to come, what all I was able to capture. Okay? So let me just see if questions at this point. I'm going to ask the room. Sir?
What is the benefit of, if you ignore a packet, changing the field? I mean, you're hiding it from display, but it's still there, right? So if you forget to disable the filter, you don't go back and go, I don't have any reset in reality they are.
Yeah, so the question from the floor was, make sure I got this right, like what's the benefit of ignoring a packet? Well, like in this case, I wanted to test to see how that affects the conversation completeness. For me, just very honestly, that is a feature I very rarely use. I think...
I can say ignoring it, but changing the TCP completeness, I don't see why would you want to change the value?
Oh, why would I want to actually change the value? Just because I'm learning about it. So the question in the field was, a question on the floor was, why would I ignore a packet just to impact the TCP completeness number? Like what benefit would that have? Literally just to tinker with it and see how it works. Yeah. In a real environment, I probably wouldn't do that. In a real environment, to be honest, I don't know until this I've ever really needed to ignore packets too much. I mean, just here and there. But Saki, you had a comment? Can you give him the mic? Hang on a second.
One reason I use it is if there's, for instance, 2 VLANs in a routed situation like we had in the packet doctors. I can filter on one VLAN, ignore all those packets, and they're left out of the analysis, and all your duplicate ACKs and your retransmissions are gone. So it sometimes helps in the analysis if you just ignore part of the trace file without having to save it to a new file. So that's one of the reasons. Another reason is development, like you want to see how this actor behaves when certain packets are there or not there. So that's the reason why I use it. And of course, in this case, for demonstrating how a field works, it's also nice. But in troubleshooting, sometimes I get disturbed by some packets, and I just ignore them without having to save it to a new file. So that's what I use it for.
Thank you, Saka. Our moderator was like, "Hey, Saka, why don't you just keep the microphone?" I think that's good no matter where that guy sits. Okay, great question. Anything else? Any other questions either in the sky? I'm going to check right here.
I have a question.
Sure.
So I just pulled up a PCAP from one of your earlier classes, and it's got a conversation completeness of 30, and I'm not seeing how that math adds up.
Ooh, which one was that?
It's Lab 12 Data Exfil.
Look at that. We're giving them a sneak peek on our threat hunting. All right, and packet number? All right, I can find it. I guess I could filter for it. TCP Completeness 30.
Looks like it starts with 1058.
Okay, let's walk through. Let's just do this first. I'm just going to do a conversation filter just to make sure we're just honed in on that one for tuple. Okay, so here we have a complete, so we have a SYN, SYNAC, ACK, we got data. Fin, FINAC, fin. Yeah. I wonder if there's something about this SYN where it's not adding it for some reason. Ports are the same, IPs look good. You found a good one. I don't know. Any ideas? Looks pretty complete to me. Nice job.
I don't have this trace file, so I can't check it.
I know there's something. Let me just double check the flags. Is there something here that's not?
Did you filter on the stream? I guess you did.
Yeah. I got the full handshake and I've got the full teardown. And data exchanged. Sorry?
No, the question is why, like bit 0, so the value 1 should be there because the SYN is there. So it should be in the completeness, but it isn't.
This is,
This is a bug. I
This
think.
is, yeah, this must be a bug. Hey.
So-
Nice.
Can you send me the trace file?
Sure,
Trace?
yeah.
Later, not now.
Yeah, no problem. Yeah, but that is interesting because at least it should be, if I have the first packet of SYN, I'm always dealing with at least an odd number, right? Because it's a 1. So if I have a 30, then the missing packet here is it's not registering the SYN. By the way, just so you've all seen it, close this down and bring up. This is actually the logic behind the TCP completeness field. Okay, so all right, so display the TCP conversation completeness is actually that field itself. So if we take a look at the different possibilities that will result in this output. Okay, so incomplete SYN sent, I'm just going to see the SYN. So if I do see a TCP thread that has a SYN, it's going to be true here. It's going to flag that. And that's going to be just output as SYN sent. If it's client established, then I see the SYN and I see a SYN-ACK. All right, so client side is established. SYN sent, SYN-ACK, and then ACK, established. Incomplete. Okay, incomplete with data. Full handshake with data. And this is where things can get interesting. I have a few different options here. I've got complete with data, then it puts the value here. The different cases. I have a handshake, data, fin. I've got a handshake, data, reset. Or I've got a handshake, data, fin, and reset. at the bottom. Any one of those possibilities will result in complete with data. Then I have complete no data. So here's all of our possibilities. So handshake fin, handshake reset, handshake fin, and reset, all in the same thread. And then I have incomplete. All right, so if you ever forget this and you really want to go digging, I mean, this is right there in the code. We can go find how that feature is, or what aspects it's actually looking for. We got a question from the sky.
Yeah, from Marco Evans.
Hi, Marco.
Why would there be no window scaling factor even though there's a three-way handshake?
Oh, in the previous PCAP?
Yeah.
That's an interesting question. Let's find out. He says, why is there no window scaling factor? It's not supported. So we got our scale. Does this guy have it? No. So, okay, we're going to tangent for just a moment here. On the connection that was found to have a bug, if I send a SYN and I've got my TCP options in the SYN, I'm advertising an MSS, a window scale, and SAC permitted to the other side. I'm telling the server these are the TCP options that I want to use. Server comes back and says, I'm only doing the MSS. That's it. So now if both sides do not support window scaling, then neither side gets to use it. If both sides don't support SAC, neither side gets to use it. So this is an advertisement of the capabilities of the server. The server's not advertising those options. That's why when I get down here, no window scaling used. Although there was a scaling factor from client to server, we don't get to use it. So that was a really good question. Go Marco. He caught that. Okay. Good. So that was one thing I wanted to show you. The other thing is if we actually go into the Wireshark, the user guide, the actual full-blown manual, wireshark.org docs, you can get to this document. This goes floor to ceiling on the TCP analysis options and how they work and what features to look for. It explains some of that. If we come down to the very bottom of this is where all these little values do come from. This is where we can learn a bit more about this feature. Conversation completeness, and here's those values that I was telling you about. So really this part of the of the guide was what stirred up the idea for me for this session. I was like, okay, what's the likelihood that people have seen this yet? I mean, maybe you go dig through the user guide. That'd be awesome. Good for you. I don't. So this was a new feature. When I found those values, and I'm like, wow, this needs to get out to the world. People need to know about this because it's a new thing that kind of happened under our noses, right? So later on, you can check out those values and see how Wireshark comes up with those conversation completeness metrics. All right, so you know what I'm going to do? This wasn't a very long topic, so I'm not going to belabor it, but I wanted to introduce everybody to conversation completeness, get you an idea of how that number is derived, some suggestions on how to use it, and maybe some ideas for some filters. If you have any other questions, please stick around and ask me. Let me just check on the chat to see if there's any more.
Somebody's asking if it's not a bug and if it is possible for it to be malicious packets.
Possible. I'm thinking bug, though. It's a new feature. Maybe. We'll see. We'll check. I like the way you're thinking, though. All right, everybody. Thanks for coming. If you have any other questions, come up and let me know. Otherwise, I'll keep the webinar open and answer anything else that comes in. All right.